Hello, and welcome to a video tutorial series on the Bevy game engine. Bevy is a game engine written in the Rust programming language with a strong ergonomic entity component system model. The engine is in very early development, and their official docs even say not to start any large projects with Bevy, but I think this has great potential and more people should be trying the engine out. I also think it's completely usable for many smaller projects, and they just finished the first official Bevy game jam on itch.io. The goal of this series is to add some more video content to the Bevy ecosystem and to show the creation of a simple game from beginning to end using most of the features of the engine. I'm assuming some basic Rust knowledge, but Bevy is designed in a way that I think it will be accessible even to people with a very beginner knowledge of Rust. In this tutorial, we will create a window and draw a sprite from a sprite sheet onto the screen. This series targets 0.6.1, which is the current version of Bevy as of March 2022. The engine is in active development, so many of the details presented here will age with time, but the core idea should remain relatively stable. I'm working on Linux, but I hope nothing that I say is Linux specific. All you'll need is the ability to run cargo, a Rust install, and I will be using VS Code for text editing. The game we will be making is a simple 2D RPG style game like Pokemon. You can see the current work on the final project on the GitHub link below. As of the recording of this video, the game is in the state you see now. The graphics are still simple placeholder graphics, but you can see many of the core gameplay systems we will be creating. There are also some other great resources that you should check out if you're trying to learn Bevy. Specifically, the best resource, in my opinion, is the Bevy cheatbook. I highly recommend checking there first whenever you're trying to learn a new feature of Bevy. There's also the official examples, which will show you code snippets of how to use every single feature of the engine. Finally, you can build the docs yourself using cargo doc, and you can see the exact interface of every function in Bevy. Now let's finally start making a game. First, we need to create a new Rust project using cargo new. This will create the standard Hello World Rust program and initialize a Git repo for us. Next, let's add the basic dependency on Bevy to the cargo toml file. We're going to steal a trick from the cheatbook and set the optimization for all engine code to level 3, even in debug, meaning we'll have a longer first compile, but the engine will run much faster as only our code is in the unoptimized debug state. We'll also link dynamically to the engine, which should give us faster compile times. It's important to note on release that it's recommended to remove the dynamic feature to allow you to ship only the executable and assets without needing the dynamic library files. Now we can build the engine, which may take some time, but this is a one-time thing, and for most of our day-to-day work we will only be building our own code, and not the entire engine. This is a core part of Bevy's design, and it helps with fast iteration times. Finally, we are ready to create a window. First, we need to use the Bevy prelude, which will give us all of the core features of the engine. Then in main, we will create a new app, add the default plugins, and then run the app. This uses the builder pattern, which is common in Rust and Bevy. The default plugins will create a window for us and set up most of the engine's main systems. We will come back in the future to discuss what a plugin is. Now if we build and run, we'll have a nice blank window. I'm going to use this time to swap into VS Code and show my setup for Bevy projects. I use the Rust Analyzer plugin for VS Code, and for Bevy I use a task to format and run the game, which is mapped to Ctrl-Shift-B by default. If you need to use breakpoints in debugging in VS Code, I often turn off the dynamic feature in the cargo toml, which will allow the built-in VS Code debugging utilities to work. If anyone needs help with this, I can make a short video showing the process. Now we are going to start using more of the Bevy ECS features. The first one we will cover is resources. The simplest resource is the clear color, which is a simple wrapper over a color. A resource in Bevy is something that there will only be one of in the game, which makes it easy to access the single instance of this data from any system in the game. Clear color will be used by some of the default rendering systems to set the background of our window. All we need to do is call add resource on the app builder with an instance of clear color. Next we will add a Windows descriptor resource to the app. This will set up basic features such as vsync, target resolution, window title, and if the game is full screen or not. Once again, this resource is used by internal systems to set up the initial window. One thing to note is I'm choosing to turn vsync on, which will lock the frame rate usually around 60 FPS. Bevy is a parallel engine and will often use 100% of the CPU and run at a very high frame rate. Currently, there isn't a great way to limit this for debugging, so I keep vsync on and some other tricks that I'll show in the future to help reduce power usage. There are open issues on Bevy's GitHub discussing this in more detail. Next, we're going to create our first system. I've resisted discussing ECS before now, but I think it's time. Basically, Bevy is built around systems, which are just simple functions that will run on groups of objects in the game. These objects are called entities, and they're made out of components. More specifically, systems run on groups of components, where components are just any Rust data structure, and entities are IDs that will connect different components together. I hope this makes some sense, and it should all click by the end of this series after seeing many examples of it in action. There are also many other explanations of ECS out there, such as Unity's documentation on their ECS. The ergonomics and ease of use of Bevy's ECS is one of its most impressive features in my opinion. Our first system is just going to spawn a simple camera. We need a camera to render anything we draw on the screen, as rendering and cameras are handled by another one of the systems in the default plugins. To create a system, we just define a function, and for the parameters here, we only need commands. Commands are how we create new entities and add and remove components on existing entities. I will cover commands in more detail as we go on. One important thing to note is commands are run at the end of the frame, so you won't notice the effect until the next frame of the game. Think of the command object like a queue of tasks for the engine to do at the end of the frame. Now we are going to create an orthographic camera bundle. In Bevy, a bundle is just a group of components packaged for easy use. I'm going to change some of the defaults on the camera to create a normalized coordinate system for our game. Basically, I'm just making the y values range from 1 to -1. I also want to set the scaling to none so we'll get a simple pixel art game. Finally, all we need to do is call commands.spawnBundle, and this will create a new entity with all the components in our bundle. In the app builder, we need to remember to add our system, and because it only happens on startup, we make it a startup system. If we forget to do this, we'll get a dead code warning from Cargo, so I recommend keeping that warning on when using Bevy. Now we have a window and a camera, and it's time to start drawing something. I'm going to use an ASCII code page as some simple starter graphics, but these techniques should work with any sprite sheet that you create or find online. You can get my graphics from the GitHub repo for this project if you want. To use graphics in our project, first we need to create an assets folder. It needs to be named assets for Bevy's asset manager to find our files. Then we put our image into the folder. Now we need a system to load our asset into the game. This system needs to use commands as we will be adding a resource to our game. It will also need to access the asset server resource that the default plugins add. This is the syntax for accessing a resource immutably. And we will need a mutable reference to the texture atlas asset manager. This syntax is a bit much, but the basic idea is we'll be getting a map of all the loaded assets of the texture atlas type, and we will add our loaded sprite sheet to that map. To actually load the image, all we need to do is call assets.load, which will return a handle to our image. Bevy gives us lightweight handles to pass around for all of our assets, and the raw data of the image is handled completely by the engine. Next, we want to create a texture atlas out of our image, as it's a sprite sheet we will use with many different sprites in the game. I've opted for an image with padding, and I recommend all sprite sheets to add padding around each tile to prevent the bleeding of pixels from one tile to the next. This is a common problem that happens in many engines, and padding the tiles is the easiest fix I have found. Next, we will add our atlas to the texture atlas's resource, which will give us a simple handle for the atlas. Finally, for ease of use, I'm going to create my own resource called ASCII sheet, which will hold a copy of that handle. This makes it easy for any system in the game to get its hands on this specific handle and to spawn a sprite from it. So in review, we load the image, then we define the image as a texture atlas, register the texture atlas, and keep a reference to that atlas in a custom resource. Let's add this system to the app builder. One thing to note is we want this to run before any other startup systems, because we'll be expecting the atlas to exist. Ordering by default in Bevy is random, but we have many ways to force systems to run in specific orders. The simplest solution here is to add this as a startup system to the pre-startup stage, meaning that this will run before any other startup systems. We will cover more ways to order systems as we go on. Now we're ready to actually draw a sprite on the screen. We could have done this in the load ASCII function, but in the long term it's better to keep these separated. Our spawn player system needs commands as we are planning on spawning an entity, and the resource we just created to get the graphics handle. We create a texture atlas sprite and we'll set the index to 1, as this is the smiley face on our sheet. Then we can set the color and size to fill our screen. Finally, we'll call commands.spawnBundle to spawn a sprite sheet bundle in the center of our screen and give it a copy of the atlas handle. We set Z to 900 because we want this to be on top of most things in the game. By default, 0 to 1000 are visible Z values, and high numbers render on top of lower ones. We also add a name component to the entity, which is good practice and will help us when we look at debugging in the future. Now if we add this as a startup system, we'll see our smiley face on the screen. One more thing I want to do is give this a background, as the smile is transparent. I'll follow the same basic steps to create another sprite sheet bundle, but now with just a gray square. I set the transform Z to -1 because it will be relative to the player. Then I get the return value from commands to get the IDs of the two entities we just created. Then I use another command to set the background as a child of the player. There are many ways to set up entity hierarchies in Bevy, and we will cover managing this as we progress in the game. We have covered many of the most basic features of Bevy, and we have created some systems, entities, and our own resource. I hope this was easy to follow. In the next episode, we will make a simple tile map, handle input, and handle player collisions with the tiles. There will also be a text version of this tutorial linked on a blog in the description for your reference. If you have any questions or suggestions, please let me know in the comments down below. Thank you for watching.